Thanks. So, can you hear me? Yeah. Okay. So I'm going to talk today about a couple of tools that we did, really small tools that we use for looking at our processing projects, and that have been very useful for us, and hopefully will be for you as well. So a bit of a presentation of what these tools are and are not. It's not it is not a Relion GUI. If you're looking for that, you would probably should look into .pos that was presented here yesterday. What it actually is for us a way to make on-the-fly processing in Relion a bit easier, because it allows you to see how your data set is going in real time. We use it as a graphical way to filter star files, which is, I guess, positive for those that are a bit more command line averse. It is open source because open software accelerates science and so on. Contributions and feedback are really highly appreciated. It's been, as I said, it's been very useful for us, and that's why we wanted to share it with the rest of the community. It's written in Python. It uses a combination of Plotly, Dash, and Alistair's star file. So it's a combination that is very flexible and allows to easily implement new things quite quickly. And it's basically a side project that we started for fun. Yeah, and it's been fun. These are the two tools I'll be talking about today, the live dashboard and the analyze dashboard. The first of them is the live dashboard. It's a small web-based tool that lets you visualize and filter the data as it's being pre-processed as it comes out of the microscope, which for me is the same than saying that you can see how bad my grids look in real time. So this is how we use it. You start your data collection, launch the Relion It tool, which is a tool included with Relion to automatically process your data. And the movies, as they come out of the microscope, are imported, motion corrected, and the CTF parameters are estimated, as you would normally do. We've inserted here a fourth step. We use a very simple Python script to estimate ice quality. What it does, the intention of this script is keeping micrographs that look like the ones in the left and discarding the ones that look like the one in the right. For that, this program basically sums up the signal that appears at the frequencies where ice usually shows up. And for us, it's been correlating very well with both thicker ice that you might want to get rid of, and also with the presence of contamination of crystalline ice. Once all of these four steps are over, the movies are automatically filtered using manual thresholds that are established manually, and the cycle goes on and on. This is how it looks. It contains a movie counter, basically how many movies are left to be processed. It features interactive plots where you can zoom in, pan around, play with the scales, inspect individual micrographs. And as I said, it has the possibility to add manual thresholds for filtering movies in real time, inspired in how Warp does it. And finally, you can readily take a look at individual micrographs and their CTFs in a micrograph and CTF gallery. Here's an example of what it would look like. After setting up data collection and pre-processing, you can take a look at how the parameters, the CTF parameters and motion correction parameters are looking. You can see a few outliers there in the figure of merit. When you inspect them, you see that they are actually micrographs in the foil instead of in the holes. You just apply a manual threshold, get rid of them, and that would be it. Still, we still have a few bad micrographs, and because they have really thick ice or ice contamination, to get rid of them, We once again apply a manual threshold, and they're gone. Now, these micrographs will be automatically exported into an star file and imported back into Relion using the Relion it.py tool I was talking about before. Yeah, and the cycle and the cycles go on, and then you can go on and pick and process your particles as you normally would do. The second tool I'd like to talk about is the Analyze dashboard. It is designed to be a kind of a companion for Relion while you are processing your data, so you can plot the parameters in your particles and your micrographs graphically and look at them and look for trends in your data. It is divided in several tabs. The first of them is an overview of your processing pipeline. It is interactive, so you can zoom on it, pan around, see how your jobs are interconnected. And when you click on any of the nodes, you get some of the information of how the job has been run. This is very similar to a part of Doppio, I think. It is also a really good indicator of when your processing project has become way too complicated. So, yeah. The next two tabs are a bit more analytical. They are designed to look for the presence of trends in your data, as I was saying. They allow you to plot either individual micrographs and particles as individual data points using any of the variables present in the star files. Here, in this case, we've plotted a set of micrographs by their maximum resolution in CTF and their figure of merit. You can easily see that some clusters of micrographs appear, and maybe they share common features. So analyzing them individually would be quite straightforward. You choose any job that contains micrographs. It is automatically plotted. You can see already that there are a few outliers. If you want to focus in a certain area, you just zoom in, click on individual points, and see how the micrographs look like. After inspecting your micrographs and deciding on a subset of movies that you'd like to inspect more closely, you just use a lasso tool, draw around the data points that you'd like to further inspect, give them appropriate name, and export them into a star file that can now be imported into Relion and for you to go on with your processing. The next tab, Analyze Particles, is conceptually the same. You plot particles as data points using any of the variables in the star files. This is one of the plots we found most useful. You're probably very familiar with it. It's just the angular distribution of particles, tilt versus rot. One of the things that is more useful from the dashboard is the possibility of adding a third variable to the plot that is represented as color. In this in this specific data set, we have particles that come from two different grids, so two different conditions. And when we color them by optics group, we realize that in one of the grids, the particles were oriented showing only a couple of views, while in the other condition, the views are more spread in the orientational space. So this is a bit of a silly example, but it's just to show how easy it would be to troubleshoot your data with this. Of course, if you wanted to focus on one view for some reason, you could use the lasso tool again, select the particles that you like, and export them. Okay, so the next three tabs are not so analytical or interactive, but they are more of a collection of data about your jobs and how the jobs have evolved across iterations in case something's not working and you want to diagnose it. The first of them, the 2D classification tab, allows you to choose any 2D classification job that you might like to see, and you get data about the convergence of the job that you can estimate using different parameters. You can plot whatever you want across iterations, and also the distribution of particles, the number of particles per class across iterations. If you want to visually take a look at your class to the averages, you don't have to go back to Relion. You can just use this shortcut and it will automatically execute Relion and to display your averages. Yeah. Okay, so next up, 3D classification, conceptually the same, but it has a bit more information given that we are dealing in 3 dimensions now. You select any 3D classification job you might have in your Relion project, and you get information about, again, convergence, number of particles per class, and how it evolves across iterations. And you get now also an orientability plot per class. So you can take a look at how well each class looks. And the most important thing, maybe the most useful, is that you get the angular distribution per class, because in my experience, sometimes Relion would classify views instead of different specimens. So you would very easily see that here. To display the classes in the classical Relion way, you just, once again, use the shortcut. Or now that we are talking about volumes, you could use Chimera, which is a bit more convenient. So we added also a shortcut for it. Yeah, a slow one. Yeah, there you go. Okay, and the last tab, it's dedicated to 3D refinements. It's basically the same information as 3D classifications because they are very similar kinds of jobs. But we've added here the gold standard FSC, because that's probably one of the most important things that you get in every iteration. If you're impatient like me, one of the coolest features of the dashboard is that you can follow the jobs as they go. So you can see how the FSC evolves across iteration, how your resolution increases if you're lucky. But I've learned that looking at the job while it runs doesn't make it run faster. So just so you know. Okay, so that would be it. Just to wrap up, these are, again, the 2 tools we've made. They are very simple, but they've been quite useful for us in the last few months. They have helped us troubleshoot quite a few problems. So if they could be of any use to you, please check them out in our GitHub. And lastly, just wanted to acknowledge Rafa and Emma, who are part of this coding in your spare time team. Alistair's Starfile library, which has made very easy to work with Starfiles. And also we wanted to talk a bit about David Sila's personal project, Follow Relion Gracefully, that has a lot of things in common with ours, and it's also really cool. And finally, my lab, led by Oscar Yorca, and the neighbors, the lab led by Rafa. That's it. Thanks for your attention.